Hello, everyone. Good morning. My name is Jorge, and I am one of the members of the UFMG Alt Protein Project here in Brazil. And on behalf of our team, I'm thrilled to welcome you to the first session of our new seminar series that's called Cellular Agriculture BRICS for the Future. We're here today with Dr. Erika Jorge, Dr. Karthick Velu, and Mr. David Omale from Brazil, India, and Nigeria. And this panel is particularly close to our hearts because it aims to highlight something that we're strongly believing, that countries on the global south can and must lead the way when it comes to sustainable and equitable innovation on cellular agriculture and alternative proteins. While cellular agriculture is actually still emerging globally, it holds tremendous promise to address some of our most pressing food, climate, public health challenges, many of which disproportionately can impact our countries and our regions. And yet, our countries have unique assets such as strong public universities, rich biodiversity, growing scientific ecosystems, and more importantly, a shared commitment to inclusive development, which is highlighted here by this sort of cooperation that we are trying to figure it out. For today's discussion, we're focusing specifically in Brazil, India, and Nigeria, three countries with diverse paths but shared aspirations. On late seminars that we are going to develop, we'll have other guests from other countries as well, from the global south, and even from the global north, and how to make this cooperations between north and global south. So particularly Brazil, we are the world's fourth largest food producer, the largest exporter of soy, beef, and poultry, and we're at top three of many of other food ingredients. We hold over 12% of the planet's fresh water, which is critical for agriculture, and a massive potential for sustainable protein production using renewable energy, since our energy source is mainly from rivers. We are also a strategic player in the discussion of land use, deforestation, and green innovation. So we've been on this cutting edge since the 70s. In India, is the largest milk producer globally and the second largest in rice and wheat, home to over 1.4 billion people, the largest country in population in the world, thus representing a major consumer labor and market. Also, strong government push for food self-sufficiency and innovation, and hosts a growing alt protein ecosystem, actually, supported by major public and private players, essential in South-South cooperation and technology transfer. And the third player today that we're going to discuss is Nigeria, which is the most populous country in Africa with over 220 million people, like almost as big as Brazil, or very likely surpassing Brazil in the next years. Fastest growing population in the continent, projected to be the third largest globally in less than 30 years. Strategic location in West Africa, so influencing regional food trade and innovation throughout the Atlantic as well, and high investment and interest in food tech, aquaculture, and agriculture startups. Also worth noting that Nigeria has officially joined BRICS bloc as a partner recent this year, which makes this conversation even more timely and relevant, actually. And lastly, what connects us is more than geopolitical groupings. I'd like to address that. It's a collective ambition that we actually have to shape the future of food in a way that would reflect our country's values, realities, voices, and also the enthusiasm that we have towards this technology. With that, I'll briefly introduce each speaker before handing the floor to them. We have in Brazil, representing Brazil, Dr. Erika Jorge, a professor at the Federal University of Minas Gerais, and is currently a researcher in cultivated meat and fat. We have representing India, Dr. Karthick Velu, who is an assistant professor at the Satyabama Institute of Science and Technology, focused on developing edible scaffolds for cellular agriculture and establishing fish cell line. And lastly, representing Nigeria, we have Mr. David Omale, who's a research assistant in food microbiology and biotechnology at the Department of Food Science and Technology at the University of Nigeria, and is also the leader of the at the University of Nigeria APP, which is the Alt Protein Project. It's a pleasure to have you all, and I'll make the proper introduction of our first guest today, which is Dr. Erika Jorge. Dr. Erika Jorge holds a degree in biological sciences from the Federal University of São Carlos in São Paulo, Brazil, and a master's and a PhD degree in agronomy from the University of São Paulo. She's also completed a doctoral internship and a postdoctoral studies at King's College London and Harvard Medical School in Boston, United States. And she currently holds a position as associate professor in the Department of Morphology of the Institute of Biological Science at the Federal University of Minas Gerais. She has experience in animal biotechnology, gene expression, cellular and developmental biology, with an emphasis on muscle and bone development. Today, her research focuses mostly on muscle hypertrophy, bovine cell immortalization, and cultivated fat. Erika, it's a pleasure to have you here. The stage is yours. Erika, sorry, but I think your mic is off. We cannot hear you. Nope. Is your mic off on the platform? It's on. Technical team, help me.
Not yet. I got it.
Very good.
Yeah,
Perfect.
sorry.
Perfect.
Sorry about that. Sorry about that. I was saying thank you, Jorge, and the APP project for organizing this important meeting and for inviting me to be the first speaker. I'm going to show you the works that is being developed in Brazil. Okay, so first of all, since I don't know who is watching our seminar, I decided to start with the definition of cell agriculture. So, cell agriculture is a new field, a new science field that uses cell cultivation to produce food, tissues, and ingredients such as meat, milk, egg, eggs, leather, and control it in a controlled and sustainable way. We are talking about cultivated meat and cultivated fat. We are talking about animal-free dairy, functional ingredients, and functional ingredients like collagen, insulin and casein, and also about leather and silk without the need of the animal. Why is that important? Because we are facing problems with gas emissions, use of land and water. So, cell agriculture is a technology that promises to be more sustainable and to produce less impact in the environment. So, with the whole process working, we believe that we can reduce the greenhouse gas emissions and reduce the use of the land, the drinkable water, and natural resources. We also believe that as a new technology, this has a huge impact, can have a huge impact in the market. So showing an economic aspect that is important for the world. We can also, but we still have to work in the costs, in the scalability of the process. But we have a huge opportunity to make a different world using this technology and to try to feed people. So cell agriculture is involving two technologies, at least mostly two techniques, that is tissue engineering, that involves cell culture onto a substrate called in the field as scaffold. So using this kind of technique, we can build tissues, and tissues to be grafted if you think about medicine, but you can tissues that you can eat or use when you think about the agriculture. We can also use the other technology that is used in cell agriculture is the precision fermentation, which is using the genetic engineering to introduce genes in microbe species and grow these in huge quantities, so you can make the products in a fermentation process instead of using the animal to produce these ingredients for you. So these two are the main techniques involved, used to promote cell agriculture. Talking about Brazil, that I think it's the main reason of this meeting, this first seminar. In Brazil, we have the most of the science produced in Brazil. I produce it in universities. So here I have a few universities all over the Brazil country that is working, that shows some initiative in the field, in the cell agriculture field. I want to highlight, of course, our university, that's Federal University of Minas Gerais, but I also want to highlight the Food Tech Institute, which is, we call ITAL, which is in Campinas, in the state of São Paulo. We also some strong initiatives in Unicamp, University of São Paulo, Paraná, which is another state in Brazil. We have also two universities of this state that is working with this field. Santa Catarina, but we also have some initiative in Bahia and even in Amazonia, because we have here a huge potential in biodiversity, but they are working especially with plant-based ingredients. So in Brazil, we have these universities, but all these listed universities, they are working in the field. We also have one public and two private companies in Brazil that's they are working in the field. So Embrapa is a government company. They are all over the country, and they are working with cell agriculture, especially they have a lot of plant-based, but they are starting to work with cell agriculture now. JBS, which is the largest company, largest food producer company in the world, which is a huge company, and they established a building in the south of Brazil that is to produce technology to produce cultivated meat, and the BRF also is another private company that is working, trying to produce cultivated meat. We also have a few startups in Brazil, but they are already producing some work. So Mundo is a startup trying to produce leather and pig meat. The Future Cow is producing milk ingredients. And Cincinnati Pieces is trying to produce, no, they are producing fish meat. And they are establishing Rio de Janeiro. So here I have a brief, a map with the main institutions working in cultivated meat. So you can see the Southeast and as the concentrating the most of the institutions working in this field, but we also have something in other states. Talking about regulation and legislation, in Brazil we have an institution called Anvisa, which is the institution that establishes the regulatory path. So these products can be approved to be commercialized in Brazil. They say that they already have this path ready. And then the products also have to be approved for MAPA. MAPA is the Ministry of Agriculture in Brazil, and they establish the regulation. They regulate the registration, the labeling, and inspection of the products. And then we have the Congress that is starting discussing this field, this possibility of these products in Brazil. So we have some debates that some deputies that are trying to prohibit, and also some that are pro-innovation, and they are positive about this technology. So we are still fighting. We still need to fight to have the legislation about these products. No cultivated meat product was yet approved in Brazil to be sold, and approval requires, as I said, Anvisa and MAPA to be controlling all the process. I'm using the rest of my time just to say what we are doing here in Minas Gerais, which is a southeast state in Brazil. So Luciana Andrade and we are working mostly in cultivated meat, cultivated fat. We are also trying to develop a bovine satellite cell immortalized cell line. And we also starting working with pork, cultivated meat, cultivated leather, and I cannot see, but just a second. I forgot. And micro careers, sorry. Micro careers development. We started working with this field since Aline Silva and João Santos from Cefet, which is another institution in Minas Gerais. They developed a nanofiber from using cellulose, acetate cellulose, and we produced a nanofiber, and we use this as a scaffold to try to grow muscle and fat cells. And actually, we could grow muscle cells. They enjoy it a lot to grow onto these scaffolds. So we proved that they form muscle differentiated muscle when they are growing onto this scaffold. And we also try to grow fat cells attached to these nanofibers, and we could also produce fat cells, nanofibers with differentiated fat cells producing lipid attached to this nanofiber. And then our proposal is that, sorry about this, we are proposing to stack layers of muscle and fat cells grow onto each of these nanofibers, and then we could produce. Here we can show you our muscle, cultivated muscle containing only muscle cells. And here we are showing only fat cells grow onto the scaffold and then fry it. And here is our product, our final product, which is nanofibers cultivated with muscle and fat cells stocked as a piece of muscle, a piece of meat, sorry. So here you can see the final product, and here the fried product as a chicken meat, chicken cultivated meat. So this is only one of our products, but we have the other current projects going on in our labs here in Brazil. This is all. Thank you very much. I'm ready to take any questions.
Yeah, that's amazing. I'm suspicious to talk about it because I was part of some of those projects.
Yes.
Thank you very much, Erika. We are going to have a Q&A session at the end of our round of presentations in this panel. So I will stimulate everyone who's watching us to drop questions on our YouTube live, please. And that we are going to make these questions at the end with all of the professors. So next, we are going to receive here Dr. Karthick Velu, who has received his PhD from the Satyabama Institute of Science and Technology in India, and is currently focused on developing edible scaffolds for cellular agriculture and establishing fish cell lines. He was awarded with the prestigious JSPS Postdoctoral Fellowship Strategic in 2019 and the Takeda Science Foundation Fellowship in 2023 to work with supermolecules groups at the National Institute of Material Sciences in Japan. And he has hands-on expertise on biorelated biomaterials, biodegradable polymers, nanomaterials for biomedical applications. His technical skills include advanced microscopy techniques such as confocal, scanning electron microscopy, and atomic force microscopy, including live cell and liquid imaging. Very nice. Dr. Karthick Velu, this is with you. Thank you.
Thanks for the warm introduction. And first of all, I would like to thank the organizers for giving me this opportunity to share the stage with Professor Erika and David. So, yeah, like I said, it's been a huge opportunity, and it's a topic that is very much needed for our society. It's very timely. Without much, I will just go to the slides. Yeah. So I think Erika has covered the basics of what cellular agriculture is. I'll just go roughly into some of the things she highlighted. And this is something that as a human being that we are working to uh, go for a sustainable way of producing protein. So that's what it means, and it is going to be clean and safe and sustainable. So that is the three basic things that contribute to the cellular agriculture field, and people are working toward throughout the world on achieving this goal. And this is one of the things that sustainable development goals is one of the key that is going to involve in this part of the work as well. And it comes with the huge challenges such as environmental and ethical challenges also associated with it, and how we work on it. So that is what cellular agriculture is. So I will just briefly explain what is India's ecosystem for cellular agriculture. There are government bodies who are actively working on this particular field. For instance, CMFRI and other ICT and other institutes, they are actively working on this particular field. Plus, there are companies and startups, they are actively pursuing research on how to get their products out you know, uh, to the public. So that is what most of them are working on, and some of them have got a very good funding from Government of India, because Government of India is actively promoting cellular agriculture field, considering its benefit to the society in the future as well. We've been also associated with Good Food Institute, and they are working with other companies and institutions, try to bridge the gap between academician and the industry partners. So, Good Food Institute is one such organization who is actively taking part in that aspect. And like I said, the market is huge. It has very big potential in changing the ecosystem of India. So, and we as a researcher, we should contribute to the this agenda as well. So that is what we in India we are trying to promote. And yeah, I will just go briefly into the work that we do in Satyabama Institute of Science and Technology. So I am associated with Center for Ocean Research, and here we have got a very good facility to do the cellular agriculture. And here we are trying to create a lab-grown meat using two aspects by taking plant-based scaffolds to support fish cells, and as well as creating clusteroids to produce meat-like tissues. So we are working on two different aspects, and we have got a very good facility. Like I mentioned, we have got a clean room and very good microscopic suit, and then all the basic stuff you need for doing the cell culture activity. Yeah, so this we are doing on we are about a team of 5 to 6 people, and we are working on 3 or 4 different aspects. So one is how to create a scaffold using a tubular architecture. So we have created a product, and we expect this to be patented soon. So this is a tubular extrusion which has been fabricated with our own idea, and this has been used to scale up for the creation of scaffolds, tubular scaffolds. So this is a product that we have created, and with this we try to grow cells on it inside the tube scaffold, alginate tubes, and I can see some early success in the study as well. And the second one is how we try to create clusteroids using fish meat. So we use this we try this using a soy protein stabilized water in water thickening emulsions. This is it's quite difficult to get results, but we are seeing some early success in it. The reason being that the cell lines, they find it very difficult to form spheroids in the cluster. So the clusters, some of the clusters that we prepared exhibited a uniform shape with high porosity, and this is how it looks. I don't know if you can see clearly. But this is how it looks. So there are some early success we could see, and the other one is we usually create different scaffolds, edible scaffolds. And the problem with edible scaffolds is that there are not a lot of scaffolds that offer on a very good adhesion. So we try to enhance the focal adhesion using chemical and mechanical cues. See, for instance, we give mechanical stress or stretching with a fish cell line. Try to improve the focal adhesion so that they can be better adhered to the scaffold. So this is also one part of the study that we are doing in our lab. And two or three PhD students, they are working on this aspect as well. So this is a grouper muscle cell line that has been given mechanical and electrical cues to see how far the stretching is going and helping in the focal adhesion. So these are some of the results that we got with a different voltage. Yeah, this is a study we carried out in Japan. So this is basically developing a fish skin gelatin based scaffolds. So we thought it would be better if we could use a fish based source to get a scaffolds to have a better adhesion with the cell lines. So that's what we tried and got a very good porous scaffolds, grooves and everything, so that it can help in the cells to go comfortably inside the scaffold. So this is how it goes. The images that you see, the B and C, they are scanning under microscopes, micrographs of the scaffold, and then plus we perform the thermogravimetric analysis to check the weight or degradation status. And yeah, so India's role in the BRICS alternate protein in movement. So as we were discussing this, McDonald's in India has come up with in collaboration with the Central Food Technological Research Institute, come up with a protein sheet, plant-based protein sheet that you can customize with your burger. So this was very recently, maybe a day before, it came out as a news. So the alternate protein section, it is moving. It is moving in a good way, and it is playing its a role in the market as well. So this is something that I wanted to share with you all. And so the advantage is that India, with a huge population, we have a rich scientific talent, and there are plenty of organization trying to help. Even the government bodies, they are trying to help the startups to get funding so that they can get the product across the table. So that is there, and of course, cultural diversity in dietary needs. So big. I wanted to highlight this BRICS collaboration. So BRICS is the future. So the collaboration can help in scaling up the technologies, sharing the knowledge. Probably collaborate with each other and uh, take things the right way and ensure that the global protein supply is without any uh, stop. We ensure that the global protein supply is there, and then strengthen the food sovereignty. So these are all the things that these collaborations, pre-collaborations, can enhance the points. Yeah, so this is and Good Food Institute. We have been collaborating with Good Food Institute, and we recently had a very good session with students. So they are going to be a future. So we had a very good session with the students. Key person from Good Food Institute delivered the lecture on how we can enhance the talent building in the smart protein sector. So students were very interactive. And they had a lot of questions to our surprise. So this is a good initiative that we have taken. Yeah. So to summarize everything, the real animal-based food materials and all this thing, it's still in the lab stage, but this needs to be you know further investigated to get the product. So ensure that we do not do a lot of killing rather than cultivating the cells in lab or meat in the lab. So thereby reducing the environmental uh, pollution and greenhouse gas emission as well. So this is something that we as a human being bound to do this for the future generation, and also to create sustainable and resilient food system aligned with global climate and food security goals. So these are all the key things that I want to discuss with you all. And thank you. I'd be happy to take questions on that. I think George mentioned that we will be taking questions at the end of the session. So thank you for the opportunity again. Thank you.
Thank you, Dr. Karthik. I'm also suspicious to say because I love mechanobiology, so I really loved your data. And also, really nice to see the breaking news about McDonald's and sustainable protein production there in India, actually. Next, we're going to have Mr. David Omale, who is a research assistant in food microbiology and biotechnology under Professor Umbei Waha at the Department of Food Science and Technology, University of Nigeria. He also leads the University of Nigeria Alt Protein Project, a student-led initiative dedicated to advancing research, education, and innovation sustainable protein systems, specifically in Nigeria. David's work focuses on fermentation-based alternative proteins, advocacy for research at the intersection of food security, nutrition, and environmental sustainability. And through his activities, the Alt Protein Project in Nigeria has mobilized students, hosted workshops and conferences, and built collaborative bridges between academia, advocacy, and entrepreneurship. David is passionate about building African-led solutions to protein insecurity and believes that the future of food on the continent lies in sustainable protein research, innovation, and policy grounded with respect for local cultures and values. David, the stage is yours.
Hello, everyone. I don't know if my mic is okay. Can you hear me? All right. Yeah. So it's an honor being here, being presenting together with two expert professors. Yeah. Should I say it's intimidating? But let's move on. So yeah, I'm here to talk about the cellular agriculture ecosystem in Nigeria, and I'll first of all look at this. Yeah, we've already understood the concept of cellular agriculture. The two professors have given us an idea of the concept of cellular agriculture and what's involved in it. But when we look at cellular agriculture in Africa, particularly sub-Saharan Africa, it's, should I say, close to non-existent. I know that doesn't sound right, but I guess that's why we are here. So first of all, I'll start with this. We are all familiar with the idea of population growth, and when we look at population growth in developing countries, which include Nigeria and other African countries, we see there is a steady increase, meaning we would have to either double the our protein production, particularly animal protein production, or we look for sustainable means of producing proteins. Now, when we look at this, the idea behind increasing population growth in Africa, particularly sub-Saharan Africa, where Nigeria is the growing urbanization. So we are seeing townships or rural areas are becoming more urbanized, are becoming cities. We are seeing more industrialization happening in Africa. That means people's need for protein is going to increase in the same vein. Now, the idea is, what do we do? How do we make sure we keep feeding our growing population? The population of Nigeria is projected to increase to 400 million in decades to come. And we feel cellular agriculture is an important idea and a concept that can help us advance these sustainability goals. So first of all, we believe for the sake of our climate and for high efficiency protein systems, cellular agriculture can play a very important role in that aspect, because we've observed that to cover our milk production in Nigeria, for instance, most of our demand is being covered externally. That means we need to import more milk to cover for local demand. And that is because we have cows that are not producing milk efficiently in Nigeria. So in order to make sure we can provide proteins, particularly milk or meat, to feed our growing population in an high efficiency manner, cellular agriculture is one of the ways to do that. And now, in the context of BRICS, we understand how BRICS is an economic force. A lot of countries are joining in. Nigeria joined in January, and we've seen some level of cooperation that they are beginning to start. And the idea behind this is, how do we ensure that BRICS and other global South nations, particularly global South nations in Africa like Nigeria, can leapfrog these traditional livestock systems that we have and get to the point where we can produce meat or proteins efficiently. Now, we've also seen a steady increase in farmed land and animal populations, and projections are saying up to 2050, the farmed animal, the land used for farming animals in Africa is going to increase generally. So the question here is it just a food security question alone, or just an environmental question alone? I believe everything aligns together. All right. So Nigeria Scientific and Technological Foundations. So we have a growing biotech and life sciences research happening at universities, also at research agencies. In the context of fermentation, which precision fermentation is also an important aspect of cellular agriculture, we've seen some seasonal and microbial fermentation expertise that are beginning to come up in different ways. And in terms of tissue engineering and cell culture, which is like the central point of cellular agriculture, it's minimal, quite minimal. Most research that occurs in tissue engineering occurs in the plant tissue culture, and there is very sparse information about mammalian cell culture happening in Nigeria. But we are seeing emerging participation in terms of bioinformatics and synthetic biology, and in terms of lab infrastructure, which is also a central component of cellular agriculture systems. There are few bioreactors. We have limited access to sterile labs, and the concept of scaffold development is like non-existent. So how do we build this cell ag system in Nigeria and the global South? So first of all, look at R&D infrastructure. We talked about shared bioreactors, pilot labs, fermentation suites. We've talked about human capacity, training in tissue engineering, in precision fermentation and food safety. Also in terms of partnerships too, which is the idea of BRICS, cross-sector collaboration across academia, startups, and regulators. I believe BRICS has a framework for science, technology, and innovation. And this is where it is very, very important. We understand that for capacity development to occur, there needs to be some form of South-South cooperation. And also in terms of policy, biosafety laws and regulatory pathways. Brazil, BRICS countries like Brazil and China, also India too, are already leading the charge in terms of research and this policy side of things when we talk about cellular agriculture. So I believe this South-South cooperation is not going to work only in research alone. It's also going to work in terms of policy. What has the countries, these leading BRICS countries, done in terms of policy that other regulatory agencies in Nigeria or in Africa can learn from? So we believe these linkages are generally important to achieve all these aforementioned goals. So Nigeria's role in global South agriculture. First of all, before I move further, I will just plug this. I wouldn't say there is little happening on the continent. These are three companies here: New Form Foods, one, De Novo Food Labs, and Systematic. These three companies here are based in South Africa. So South Africa is also another BRICS countries too. So it seems like BRICS countries are doing something right, for the fact that a lot of or majority of the BRICS leading countries are into cellular agriculture. So the idea of this South-South cooperation means that other countries that are part of that are in BRICS memberships or are BRICS partners can also try to learn and gain knowledge either through some form of exchange or training or researcher collaborations. Yeah, so moving forward, what do we do? Like I mentioned, in terms of building that foundation in Africa or in Nigeria, to be specific. So we need to get some youthful science engaged population. How do we engage the population in Nigeria? There are a lot of universities in Nigeria that offer biomedical engineering, which concepts of tissue culture also comes in their curriculum. So how do we engage them? We also look at the aspect of Global South and BRICS collaborations. Do we have a platform for research collaboration that goes beyond just the trade and finance and economics, also research exchange and innovation pathways? So what are the research exchanges happening? I believe that the kind of collaborations we see in Nigeria or in Africa mostly happens with European researchers. But we need to see how research can happen more between BRICS countries, particularly countries like Brazil. Whenever I go through publications, I don't see many research that occurs in between Nigerian or Brazilian researchers. There's not so much. So I believe these are the things that needs to start coming up. So food sovereignty, how do we make sure we bring the ideas of food sovereignty and local R&D together? And lastly, call to action, and leadership vision. So who are the leaders? Who are the leaders that can promote this? How do we make sure we bring this to the forefront of BRICS engagements between our countries? So I believe I do not really have much to say. Like the others the other professors who have talked about the great and lovely work they are doing in cellular agriculture research, but we believe that with more collaboration, or with more researcher partnerships between South-South countries, we can grow the cellular agricultural industry in Nigeria and generally in Africa. Thank you.
Thank you, David, very much. I'm excited, actually. These were really, really, really nice 3 talks. I didn't know much about the Nigerian or the African ecosystem, so it was really fruitful to hear everything that you had to say, David, and Dr. Karthick as well from the India ecosystem perspective. We do have some questions on the chat. I am going to address them first, but I also have my own questions if we don't fulfill the time yet. But the first question was addressed to Dr. Karthick Velu. Amanda Leitoris is asking, thank you for the excellent presentation. We all know that India's pharmaceutical industry is a major global player. From your perspective, have you seen any movements from the industry or the scientific community towards leveraging this expertise to develop solutions for cellular agriculture, particularly in the area of culture medium for fermentation and cultivated meat?
Yes, that's a very good question. So the government of India is actively taking initiative in supporting startups, early stage startups, as well as companies in a way that they can generate fund by a scheme called Startup India Seed Fund Scheme. So that funding is available up to close to $50,000. So anybody with a startup with a very good idea, if they can pitch to the committee, and if they can convince the committee with a sound product, no questions asked, they will be granted a seed fund scheme of $50,000, which is a quite a huge money considering early stage startups. So that is one thing that the government of India is taking initiative. Secondly, the government also under the Ministry of Science and Technology, there is an government body called Department of Biotechnology. And so they tie up with government institutions, research organizations, 2, 3 organizations. They will come together in one umbrella, and then they will create a forum where they can take up the idea of startups as well as private companies. And so there are cases where they have got a huge funding, close to uh, uh, $1 million actually also. So that is also actively going on. So the government of India is taking huge initiatives, and they are always welcoming partnerships. So rather than a company with you, just you pitching the idea, if you can, team up with some very good institutions or collaborators, and if you have a very good product, say for instance, if you have a meat, lab-based meat or cultivated meat, the government is always open for ideas, and they also uh, free up the process for regulatory authorities as well, right? Because the civil bodies who are working on the regulatory authorities, so that they are actively working on that as to support companies as well. So that is one thing. The pharma part is something that we all know. India is the largest producer of vaccines as well as pharmaceuticals. So uh, this alternative protein sector is also growing quite rapidly in India, and there are companies who have got very good funding. So that is there. Excellent question.
Yeah, nice to hear that we have public and private investment walking together.
Yes.
Something Brazil needs to
Yes.
learn. Another question for you, Dr. Karthik. Less political, more scientific, is from Julia. She asked, in technical terms, what are the difficulties in work with primary fish cells? Do they proliferate well? Is there any plan to immortalize them? And
Uh,
how does that work?
I think, yeah, Erika might know this answer as well. So, see, to be honest, culturing a fish cell line, primary cell line, is quite difficult, hands down. So you have a very less chance of taking the passages to like 100 or 50, 150, like that. So usually, you take cells from a fish cell line, for example, a fin or a muscle, or maybe gill cells. The chances are that it will go to the dormant stage, maybe 20 to 25 passages. So you rarely have a chance to convert it into a very good cell line. So it is by nature. I don't know how I can answer to this, but it is quite difficult. But once there are few cell lines which has come out of India. There are who are pioneers who are working on developing cell lines in India. For instance, Dr. Shahul Amit, who has done a pioneering work in developing cell lines. I'm sure that most of grouper fish cell line, milkfish, they have developed a lot of cell lines. It is in the repository as well. It is free to, I mean, it's not free to access, but you can get the cell lines. You can get your hands on the cell lines very easily. So it is available in a repository. And there is a government body called NBFGR. So it's a fish genetic resource maintenance body by the government of India. So they have plenty of cell lines as well. So it is quite difficult, but if you can manage to culture the cell, you can put it in a repository, and then you can give it to the other people as well, to the other scientific community as well. It is open also.
Yeah, I would like to like make a flow here to Erika because she's working with bovine cells immortalization, and we all know from the background, but also from the scientific community, that this is a huge difficulty from all the markets. So, like, if you could share your insights within and making some comparisons with what Dr. Karthik just talked about, fish cell lines that is difficult to immortalize, but how more difficult it is on the bovine perspective.
I don't think it's different. I think it's the same. We have problems to select the cells, to isolate the cells, to make them grow, and to decide if they are muscle or fibroblast cells, all the protocols that works with rodent animals. They don't work with the bovine, so it's really hard. That's why we are trying to establish a cell line so we can try to have at least one cell line to work and move on, because this is not supposed to be, this is the first step of the process, and we are already suffering a lot. So yeah, I think it's the same. I think it's with this we still need like genomics and transcriptomics data, proteomics data, so we can understand well these cells, how they can grow, what are the needs to differentiate, and we don't know the cells yet. So the good thing is that we still have a lot to work, but yeah, we have to face this like the first step. The first step is being the very difficult one.
Yeah, very nice. We do have another question here from the chat to David. Amanda, David is asking you, she's actually thanking you for your presentation and then asking, from your perspective, is there a particular research topic, theme, or line of inquiry within cellular agriculture that you believe could be especially impactful in advancing science in Nigeria or potentially across the African continent?
Okay, yeah, I guess for a research topic or line of thought, I guess when you try to look at it, it depends. Are you trying to make science just for the sake of science, or are you trying to make science that can be culturally accepted? Because I feel the first thing is the cultural barriers. First of all, if you look at the concept of cellular agriculture, particularly the components where you have precision fermentation or cultivated meat, for instance, I believe the cultivated meat side of things would receive more pushback from Nigerians or Africans, because they are like, okay, it's if you're telling us that this is the real meat, but it was grown in a bioreactor, it was cultivated, people would people won't feel accepting of it. And these people's tendency to reject something might also impact the regulatory side of things, because the government won't want to take too much time or invest much time in trying to even look at the whole safety aspect of it. But I guess when we look at things coming from the, should I say, precision fermentation angle, where you can see companies are trying to produce lactoferrin, for instance, I believe the companies or researchers can maybe, in that sense, streamline the regulatory hurdles that they might face in that sense. So that is what I believe. But when we can also look at things in the cultivated side, but I feel fats could work if you are trying to make like blended products, for instance, in terms of blended alternative proteins, for instance, then maybe trying to use cultivated fats to work with plant-based meats that is already being produced in Nigeria or Africa generally, then you can, that aspect can work. I believe it can be a pathway or an entry for the development of cellular agriculture. But when you try to come and look at cultivated meat, for instance, people's attitude towards it would be much more strict, because in this sense, you are not giving them a component alone. This is like a whole product, and yeah, and Nigerians tend to like eat whole cut meat, for instance. So when you bring a whole cut meat, for instance, and you present to Nigerians and say, okay, this is cultivated, or this was made using the science of cellular agriculture, comparing it with maybe trying to make a component of a larger product through cellular agriculture, people's distaste or pushback will come more from the old courts, product, which is the meat in this sense.
Yeah, it's something that we always talk about here at UFMG Alt Protein Project as well, the ability of communication, how to address to the community that is not really uh, uh, um, educated about this new technology and how to educate about this new technology. We are running out of time, unfortunately, but I do want to make like this last one round of take-home messages from you. And the question that I wanted to make from you is like, quick introduction about all of the collaborations that we do have here in Brazil on the perspective of cellular agriculture, particularly, but not necessarily. Across sciences, we see a lot of collaborations between Brazil, United States, Brazil, and European countries, but we do not tend to see a lot of cooperations as robust as they are with the European and American countries, with other countries like India, Nigeria, or from the global south. The question that I would like to make for the professors first, but please, David, feel free to add at the end, is like, what do we have to do to increase these sort of collaborations? What are the gaps that we are not making to make Indian universities collaborate with Brazilian universities or with African universities as well?
I think Erika can go ahead.
Well, in Brazil, we have. You are wrong because I had two Nigerian students in my lab last year. So, um, but it's. I mean, we can improve that. In Brazil, I think the most difficulty is English. English, you can say. Yeah? I mean, the programs, the universities, we have like courses, the courses, and um, all in Portuguese. And Portuguese is a language not anyone everyone speaks. So I think English is a question, but I mean, uh, we should have like fellowships in, to to bring students because professors we are too busy, right, Karthick? But students we can exchange students and but we don't have fellowships, specific fellowships for this field, I guess. So we could try to to um, establish this kind of uh, paths. I mean, try to find fellowships and um, I don't know. I don't know. I think it's just money. Money is always a problem. But in Brazil, we have like a program um, that from CAPES, from government, that they have few fellowships to try to exchange students and also professors. So I mean, I don't know, Jorge. It's I don't
No,
really.
that's a good answer. That's a good answer. But I think like even though we have like the Capis sandwich program or the professor program, usually the professors still aim to go because of better relationships that we have with American universities or European universities, like your fellowship that you did on London or Boston. Yet I think like we could have like this new round of students that will make the fellowships in Delhi or in Mumbai or in Lagos. So I think that
That would be
it's
great. That would
yeah,
be
it could
great.
be a great opportunity. If you wanted to add
Yeah.
anything, Dr. Karthik.
Yeah. So I think Erika has covered the most part. Yeah, the first thing is first and foremost thing is funding, right? So uh, nowadays the government they see different problems. The government has its own agenda. It varies with country to country. And the first and foremost thing for them is to protect protect the country. So for they spend a lot in defense. So science and technology comes second to them. So there are not a lot of fellowships offered to foreign students, as Professor Erika pointed out. That is something that government can work on, because we see a lot of funding cuts to even bigger institutions like NIH and other private institutions in and around the country. So funding is something that government can work on for science and technology. So that is my maybe I don't know how many of you agree with me, but that's what I feels. And collaboration, can, of course, it will happen when two people are working on the same similar sort of work. So that will happen. And this program, to be honest, this program is a great initiative to that. Don't you agree with me? So now, bringing BRICS together, collaborations together. So this is something that I'm very happy about. We consider this as a huge step moving forward. So I'm happy in that way. I think that answers your question.
Yes, absolutely. It's a small step. We still don't have the money, but we'll try to figure that path out. I am so sorry that we have already run out of time. This has been like a wonderful conversation. It's a pity that it's a small time, that we have only 1 hour, but I'm hopeful that this will thrive in more collaborations, and at least we get to know each other better. I have to tell to the people that are watching us that this is just the first of a seminar series that we're going to do called BRICS for the Future in Cellular Agriculture Perspective. For the next seminar, we still don't know the date yet, but we are trying to figure it out, bringing people from the north, the global north, to discuss about the global south and how to make this type of collaborations as well with the countries from the BRICS, but not necessarily from the bloc. So it's been wonderful to have you all here. Please follow us on our social media, on our LinkedIn and our Instagram that are right here on the chat. And also, if you missed the link for the attendance, so that you can get a report that you got here, that you watched this presentation, it's here on the chat above. Please sign there, this Google Forms. Thank you very much, David, Dr. Karthick, Dr.
Thank you
Erika,
for the
for
opportunity.
your
It's been a
attendance.
pleasure.
It's a pleasure to have you here.
Thank you
you.
very
Thank you.
much. It was a
Thank you.
pleasure.
Thank
Thank
you.
you.
Thank you for the
Bye
opportunity.
bye.
Bye
Bye.
bye.